Bismillahirrahmanirrahim. This lecture is about the calibration of glassware, which is commonly used in the laboratory and analytical equipment. So, what is calibration? Calibration is a process of determining the accuracy of the glassware or any equipment which you are using in the lab. So, this process involves a reading from the glassware and measuring its variation from the standard glassware. So the question arises here, why we are aiming for the calibration? Why we need the process of calibration? Actually, the calibration is being done to maintain or to achieve the quality control and the quality insurance in the production by determining the accuracy of the equipment or instrument or whatever you are using in the lab. And second main objective is we are following the guidelines which are led by ISO and the global trading requirements. Number three, if you are following the ISO guidelines and world trading requirements, and you are maintaining good quality and you are assuring the quality product, then your company will be having a well repute in the world of marketing. So the fourth main objective of this calibration is to trace back the measurement results to the national or international standards. So what are the benefits of calibration we are getting out of it? Number one, we are uh, ensuring the glassware equipment or the instrument that you are using is working fine or it has some problem. आपने ये देखना है कि आपका जो ग्लासवेयर क्या सही वॉल्यूम जो आप मेजर कर रहे हैं सही वॉल्यूम चेक सही वॉल्यूम मेकअप कर रहा है, सही वॉल्यूम शो कर रहा है, इक्विपमेंट आपका सही रिजल्ट दे रहा है. इट मीन्स आपने इंश्योर करना है कि दे आर वर्किंग फाइन. The second objective, second benefit that we are getting, so better results can be obtained by using the calibrated glassware or calibrated equipment or calibrated instruments. If you are not using the calibrated equipment, glassware or instrument, then your results may have some problem, or your product may have some problem with the quality issues. So better results can be obtained, better results can be achieved by using the calibrated glassware equipment or the instruments. Then the third benefit is the fulfillment of the requirement according to the in national or international measurement standard organization. Then the interchangeability is another benefit of the calibration. This calibration basically improves the quality of the service and the product. Calibration will enhance the quality of the service and product to meet the satisfaction of the customer and the market. If you are not following the guidelines given by the ISO, then you may have some problem with the quality of the services and the product. Then you will not be able to achieve the satisfaction of the customer. Then the very important, uh, if you are if you are using the calibrated glassware equipment or instrument, then the chances of failure will be reduced. And then when the failure is reduced, then you will be going to save the power or energy. अगर आप एक चीज़ को बार बार करेंगे तो उसमें जो पावर है, एनर्जी जो है वो ज़्यादा इस्तेमाल होगी. लेकिन अगर आपके फेलियर के चांसेस कम हो जाते हैं, आप एक चीज़ को एक मरतबा करते हैं, तो आप जो पावर सेविंग जो है वो करते हैं. Definitely, if you are saving the energy, then you are going to save the cost of over expenditure. And if you are using the calibrated equipment glassware, then you are ensuring the safety of the plant, safety of the labor that are working in that premises. Okay, when the calibration will be done? This is very important question. Here I enlist some cases in which we are going to calibrate the instrument or equipment. Number one, when you purchased a new glassware, new equipment or instrument, definitely you need to calibrate that newly purchased glassware equipment or instrument. If you are using that glassware equipment without calibration, there are uh, chances that uh, you will be getting not accurate or not precise results. So in this way, you are consuming a lot of chemicals, a lot of power, a lot of costs will be used to run the equipment again and again to achieve the better results. So if you want to get better results, then that newly purchased glassware instrument or equipment must be calibrated according to the standards that will be given by the manufacturer. Second important case, when the instrument or glassware get interrupted mechanically or electrically. Sometime बिजली चली जाती है, पावर फेलियर हो जाता है, तो इंस्ट्रूमेंट जो है, इक्विपमेंट जो है, वो रीस्टार्ट होता है, तो उस इलेक्ट्रिकल शॉक की वजह से उसकी कैलिब्रेशन जो है वो ख़राब होने का ख़तरा है। तो अगर आप उसे मैकेनिकल या इलेक्ट्रिकल शॉक लगता है इस इंस्ट्रूमेंट को, देन यू विल बी गोइंग फॉर fresh calibration of that instrument. Then instrument or equipment should periodically be calibrated. This period may be weekly. Some instruments require weekly calibration, which are being used at high frequency, and some instruments or equipment are monthly calibrated, or some instruments or equipments they are annually calibrated. The fourth case, in that case uh, we are going to calibrate when the specific uses or operational hours has passed. In that case, we will also be calibrating that equipment or instrument. When you repair or modify the equipment, then you also be liable to calibrate that equipment or the instrument. अगर आपके पास क्वेश्चनेबल ऑब्जर्वेशन आ रही हैं, जो आप रीडिंग ले रहे हैं, जो रिजल्ट्स ले रहे हैं वो क्वेश्चनेबल हैं, सही नहीं आ रहे, अकॉर्डिंग टू एक्सपेक्टेशन नहीं आ रहे, देन यू विल बी required to calibrate the instrument or equipment. And very important thing is, if you are calibrating the instrument before scheduled time, then you are going to waste a lot of time and a lot of money. So calibration must be done periodically according to the specification, according to the requirement of the machine, of the manufacturer, given by the manufacturer. And rare calibration will also be uh, the waste of the product. आप जो कभी कभार कैलिब्रेशन करेंगे, विदाउट कैलिब्रेशन अगर आप कोई प्रोडक्ट बनाएंगे, तो चांसेस हैं कि वो जो प्रोडक्ट है वो क्वालिटी की नहीं होगी. Or when the weather changes, then the calibration will also be required. That instrument must be calibrated again. And two more cases, when the manufacturer recommends the calibration, And when you are going to get a critical measurements, then you should calibrate the equipment or the instrument before starting the process, because you are going to process a critical experiment and you are expecting a critical measurements. Then you will be required to calibrate that equipment or instrument. So what are the basic requirements uh, for the calibration process? Number one, the equipment or instrument that you are using and the calibration standards. It may be a chemicals, maybe a glassware, maybe an instrument. Uh, the second important thing is the controlled environment conditions. We will discuss it in detail in next slide. And competence level of the personnel involved in the calibration process. We must be looking for the some personas which are expert in their field. So the competence level will matter a lot in the calibration process. So the highly competent personas will be required to carry out the calibration process. Traceability of the references and the traceability of the calibration standards, and the final requirement for the calibration is the documentation. We must have a proper documentation of the calibration and the working of an instrument. So these are the environmental factors which should be in your mind when you are calibrating any glassware or equipment or any instrument. For example, temperature, relative humidity, illumination level, acoustic level, shock and vibration free, and the power supply regulation. Okay, these are the volumetric glassware that we are using conventionally in chemistry lab. So these volumetric glassware includes the glass pipers or the electronic piper, and the volumetric flasks, which are of different volume, ranging up to 1 liter, burettes, which are used for the titration process, and the cylinders, the measuring cylinders, graduated measuring cylinders. These commonly used volumetric glassware must be calibrated, and uh, will show you the process how to calibrate these volumetric glassware. So these are the requirements uh, which are essential to calibrate the volumetric glassware. Number one, the weighing balance, is top load balance or analytical balance, and these analytical or top load balance must be calibrated before using for the calibration process. And the thermometer, which also be calibrated uh, prior to prior to be used in the calibration process, and distilled water, stopwatch, and the glassware which are to be calibrated. That glassware must be uh, clean properly, and all the uh, debris that would be in acidic, would be in basic, uh, must be removed properly. The first glassware, which is the volumetric flask, we are going to uh, show you the process of calibration. How will you calibrate these volumetric flasks? In this picture, you can see a 10 ml volumetric flask. It's a round bottom and long neck, and on the neck, in the middle of the neck, there is a circle. There is a mark. When you fill this volumetric flask up to the mark, then the volume in this flask will be 10 ml. So in this way, you are using different volume capacity, different volumetric flasks with different capacity. These are available in the lab, in the market. So these volumetric flasks are used to measure the volume of the solution uh, which is normally used in the laboratory. These laboratory flasks to contain the precise volume of solution at a specific temperature. In order to calibrate the volumetric flask, first of all, the analytical balance was stirred, then empty volumetric flask was weighed and its weight was recorded. Volumetric flask was filled to the mark with distilled water and again weight it, then calculate the net weight and record the temperature of the water and repeat this process at least for 5 times, and for all the uh, attempts you need to record the net change in the weight of the flask and calculate its density. Burette is another type of volumetric glassware which is used in analytical chemistry for accurate dispensing of liquid, especially one of the reagent in the titration, which is known as titrant. We usually take the titrant in the burette. The burette tube carries graduated marks from which the dispense volume of the liquid can be determined. The burette is used to measure the volume of a dispensed substance but is different from a measuring graduated cylinder as its graduation measures from top to bottom. The volumetric burette can be made of glass or a plastic and is a straight tube with a graduation scale on it. At the bottom of the burette, there is a stopcock and a valve to control the flow of chemical solution. The barrel of the stopcock can be made of glass or the plastic. You can see in this picture, in this slide, there is a stopcock. You can see in a blue color. This is usually used to control the flow of the titrant, which is filled in it for different titrations. For example, acid-base titrations, uh, complexometric titration, or redox titrations. In order to calibrate the burette, it must be cleaned and washed away with the distilled or deionized water. After washing the burette, fill this burette up to 50 ml mark, which is its highest capacity. These burettes are available in market in 50 ml and 100 ml. If you are using 150 ml burette, then fill this burette up to 50 ml and make sure the tip of the burette is free of bubbles. If it has some bubbles, then drain it into the waste beaker and again refill the burette and set the water level at 0 mark. After this, test the tightness of the stopcock, which is usually used to control the flow of the titrant. The tightness of the stopcock uh, will be checked by allowing the burette to stand for 5 minutes. We will wait for 5 minutes to observe and to notice if there is any drop coming from the bottom of the burette. So during this 5 minutes, there must be no considerable change in the volume of the titrant which is in the burette. Then take or dispense then dispense 5 ml of the water from the burette into a clean and dry previously weighed container. This container may be a beaker or a flask or any other container which can contain the dispensed water. After dispensing 5 ml of the water from the burette, this volume of the water along with the container will be weighed using a weighing balance. So here one thing is very important, that if you are interested to measure the correct amount of the dispensed water, you need to, in order to measure to in order to measure the amount of solution added or which you are dispensing from the burette must be observed at the eye level straight to the bottom of the meniscus. So when you are dispensing the liquid from the burette, your eyes should be at straight to the bottom of the meniscus. The liquid in the burette should be completely free of bubbles to ensure accurate measurement. The differences the difference in volume can be calculated by taking the difference of final and initial recorded volume. So we will repeat this process for 5 times with the same volume, 5 ml of water, and you can repeat this process for 10 ml or 20 ml volume as well. Then after getting the net weight of the water, we will calculate the density of the water at specific temperature which is in the laboratory and which is of the water which is being used. Among volumetric glassware, pipette is a very important tool which is commonly used in many laboratories of chemistry, biology, and medicine to transport a measured amount of the liquid. These pipettes are also known as media dispenser because these pipettes are used to dispense a specific amount of specific amount of solvent from one place to another. So these pipettes are available in different designs for various purposes with levels of different accuracy and precision. So if we are working with a glass pipette, which is usually known as pastel pipettes, the accuracy and the precision is different. And if we are working with the electronic pipettes, that is micro pipettes, these micro pipettes was first patented in 1957 and got the commercial production in 1961. So these micro pipettes work by creating a partial vacuum above the liquid holding chamber and selectively release this volume to draw up and dispense the solution that we are using in that pipette. In this slide you can see both types of pipettes. The right On the right side there are glass pipettes which are of different volume capacity starting from 0.1 ml to 10 to 20 ml. These glass pipettes contain 0.1 ml or 20 ml of the volume of the solution that we are interested to measure. And on the left side you can see the two types of micropipettes. One is a single channel and the right one is multi-channel micropipettes. So these pipettes uses a vacuum to draw up and dispense the solution or a liquid. So there on the glass pipettes there are graduated uh, measurements on it. uh, 0 1 2 3 5 up to maximum volume of the solution, while in a micropipette there are a screw which are used to enhance the vacuum. Ultimately, higher the volume can draw up the higher amount of the solution and dispense higher amount of solution to another beaker or container. So we will use these pipette depending upon our requirement. In order to calibrate a glass pipette, uh, for example, we have 5 ml glass pipette. We will wash this glass pipette with excess of water to remove all the associated debris and to remove the bubble attached to the wall of the pipette, internal wall of the pipette. After that, we will fill this glass pipette up to the mark of 5 ml and dispense this amount of water to previously weighed container. Container means a beaker or a small flask. Touch the top of the side of the weight container and dispense the water while holding the pipette vertically. While you are dispensing the solvent from the pipette, you must keep the pipette vertical in a vertical position. After water has stopped flowing, wait 2 to 3 seconds to dispense the residue 2 to 3 drops of water which are attached to the bottom of the pipe. Then weigh the beaker and the dispenser water and record the temperature of the water with thermometer which was previously uh, calibrated. So we will use a calibrated thermometer only. Repeat this process for 5 times and then record the change in the weight of the dispenser water and the beaker and calculate its density. So for the calibration of volumetric glassware, the glassware which we were discussed in earlier slides, like volumetric flask, burette or pipette. So using these glassware, we uh, dispense a specific amount of water, for example 10 ml, and we will also record the temperature of the water, for example is 25 degrees Celsius, and after that we will weigh the empty container and empty container with water. So W1 represents the weight of the empty container and W2 represents the weight of the empty container plus dispensed water. So we will calculate the net weight by subtracting W1 from W2 to estimate the net weight of the dispensed water, and after that we will calculate the density at specific temperature 25 degrees Celsius, and then we will compare the calculated density with that of the literature. If those is two values, the calculated and the literature value are close, they have they have closeness, then the glassware is calibrated and they are able to dispense an accurate amount of water according to our requirement. If the calculated value of density of the water is far away from the literature value of the density of water, then that glassware is not calibrated, and uh, there is some issue there are some issues which will result in the wrong estimation of the volume of the solution.
The materials that you'll need for the calibration of a volumetric burette include a 125 milliliter plastic bottle, Kim wipes, a waste beaker, a stand with burette clamps, a volumetric burette, and deionized water in a spray bottle. With your waste beaker under your burette, rinse your burette with deionized water. Wipe the outside of your burette with a Kim wipe. Drain your burette into your waste beaker. Once your burette has drained completely, wipe the outside of it with a Kim wipe. Inspect your burette to make sure that there are no water droplets that have collected on the inside of it. If you see any water droplets on the inside of your burette, this would indicate that it is not clean. If your burette is not clean, contact your instructor. If your burette is clean, you should see no water droplets on the inside of it. Only continue with the calibration once you're sure your burette is clean. With your burette clamped in place, fill your burette with deionized water past the 0 mark. Open the valve to release any air that may have collected in the tip of the burette and lower the water level down to the 0 mark. Ensure that the bottom of the meniscus lines up with the 0 mark. Weigh your 125 milliliter plastic bottle on the analytical balance. Record the weight in your laboratory notebook. Place your plastic bottle underneath the tip of your burette and release water to the 10.00 milliliter mark. Touch the tip of the burette to the inside walls of the plastic bottle. Record your initial and final burette readings in your laboratory notebook. Return to the analytical balance and weigh your plastic bottle with 10 milliliters of water added. Record this weight in your laboratory notebook. Record your final burette reading into your laboratory notebook. Place your plastic bottle underneath the tip of your burette. Open the valve on the burette and release water to the 20.00 milliliter mark. Record your final burette reading. Touch the tip of your burette to the inside walls of your plastic bottle. Weigh your bottle again with 20 milliliters of water added, and record the weight in your laboratory notebook. Repeat this process in 10 milliliter increments until you've dispensed the full 50 milliliters from your burette. Construct a calibration curve based on your data. Your calibration curve will give you an absolute error for your burette.
Analytical balance is used to measure the small mass of the solute, and these analytical balances are commonly used in different laboratories for measuring the small amount of the sample. So this analytical balance contains a measuring pan which is kept inside a transparent enclosure, because these enclosure contain door to stop or inhibit the movement of dust particle and air current into the pan of the analytical balance. So this enclosure usually called as draft shield. Analytical balance are required to be monitored and cleaned away very carefully and calibrated frequently.
The analytical balance is a precision instrument used for weighing masses to 4 decimal places. The balance must be leveled to assure repeatable results. Locate the air bubble on the balance. The leveling feet are at the back of the balance housing. Turn these until the air bubble is in the center of the level control. Balances need to be clean at all times. Take a soft bristled brush and sweep off the balance tray and surrounding area. Make sure all the balance doors are closed. Turn on the balance. A warm-up time of 30 minutes is suggested for optimal performance. When 0 appears, press and hold down the control bar where it says Mode. When Cal with dashed lines appear on the display, release the bar. Cal 100 will flash after a few seconds. Slowly move the calibration lever on the lower side of the balance toward the rear. Cal with the dashed lines will appear, and then 100. When the display Cal 0 appears, move the lever back to the original position. Dashes will flash, followed by 0. Acquire calibrated weights. 50 and 100 grams are suggested. Use forceps or Kim wipe to prevent oil from your hands and other contaminants from adding extra mass to the weights. Open one of the doors and place the 50-gram weight in the center of the tray. Close the door and wait for the balance to stabilize. It is stable when the stability circle disappears. The display should be within plus or minus 0.3 milligrams. Remove the 50-gram weight and replace it with 100 grams. Close the door and allow the balance to stabilize again. Remove the 100-gram weight and close the door. The balance should go back to 0. Re-zero by pressing the 0 or OT key. Let's review the steps. Level the balance. Clean the tray. Close all doors. Turn the power on. Press and hold mode for calibration. Slide lever to rear when Cal 100 appears. Return lever to original position when Cal 0 appears. Add calibrated weights to verify calibration. Re-zero. Now you are ready to weigh.